Hi everybody, welcome to Calculus. I wanted to remind you of a quick definition of calculus. Calculus is the study of change, and we are in particular interested in change in motion. If we had met this gentleman driving in our algebra class, we would have been able to figure out his average speed from here to here, or his distance, or the time it took him to get there. But in calculus lets us find out his instantaneous speed right at the moment he might cross the stop sign, just like in the video that we watched. The other thing we think about when we're talking about calculus is the slope of a line. In calculus, we would have used formulas in algebra, we would have used formulas such as this to find the secant line. In calculus, we actually use the tangent line to find the slope of the curve in that exact position. So how is calculus useful to us right now in finding instantaneous speed? Well, one of the first things we look at in calculus is the idea of a limit. So the limit of a function is the value of the function as x gets closer to some given value of c. So say this is our sketch and c is 4 and L is 5. The limit as x goes towards c is the number or the value of L that we approach as we get closer and closer to C from both sides. So if you think about the squeezing theories that we discussed, as those red dots pull closer and closer to the blue, that tells us what the limit is. The limit of this function is as x gets closer to 4, L equals 5. So how do we know when we've got a limit? We can find a limit numerically. We can find a limit graphically. And we can find a limit analytically. To find a limit numerically, we use a table. So when I'm asking you to find the limit of x plus 3, as x is approaching 2, it's asking you to find the limit of this function. And so if we were to use a table, you have a nice neat one written in your study guide. What you need to do is pick values that are close to 2 on either side. You'll see that I have 1.9, 1.99. Notice how the values are getting closer and closer to 2. And then I jump to the other side of 2 and I pick, I'm going to have to put some, another line there, okay? And what you need to do now is plug each of these values of x into the function and see what value f of x becomes. Stop the video and calculate the values of f of x at each of these values of x, and then come back and check your answer. So as I calculated the answers, you can see that as x approaches to 2 from both sides, that f of x is getting close to 5. So the limit of x plus 3 as x approaches 2 is 5. We can also determine the limit graphically. When you look at the graph of a function, you can determine the limit as x is approaching c by looking at the function and determining the y value as it's approaching c from each side. So you will have the notation, the limit of the function as x is approaching c, with a little negative in the exponent position on the c. That means coming from the left-hand side. When there's a little positive in the exponent position of the c, that means coming from the right-hand side on the graph. And when we say x is approaching c with nothing in that exponent position, we're talking about the value of the function at c. There's two main rules that you have to worry about, and that is when the behavior differs from left and from right. So when you look at left and you look at right, if the limits do not agree, then the limit does not exist at x is approaching c. When you look at the graph and there's unbounded behavior, that is, the graph is going off into infinity as it's approaching your value of c, then the limit also does not exist. So in this particular example, I'm going to use the graph that you have already here. I'm going to take out the c, and I'm actually going to look at what happens when this function approaches 0. So when I'm approaching 0, or x is approaching 0, from the left, it is approaching positive 1. As it's approaching, x is approaching 0 from the right, so this is what I mean, if I'm following x this way and this way, then it's approaching, the function is approaching 1. So what is the limit at 0? It is 1. I would like you to take a few minutes, shut the video off, and use the same graph, which is on your paper, and figure out the limits of the other pieces I've put at the bottom. You'll see the numbers there. Come back and check your answers. Okay, so you can be looking at your graph while we're talking, and I really had to round the number a little bit. I think the graph isn't exactly precise, but I think you'll see what I'm talking about when you're looking at it. So the limit of f of x as it is approaching positive 1, from the left side is 2, from the right side is 1, and so the limit does not exist because the behavior from the left side and the right side are not the same, and so the limit would not exist. When you're looking at negative 1, as x is approaching negative 1, the function is approaching negative 1 from the left-hand side. It's also approaching negative 1 from the right-hand side, so the limit for the function is negative 1. The limit of the function as it is approaching 2 from the left-hand side, this is a 2. I know it looks like a z, but I'm using a stylus that's really kind of lousy. Anyways, this is approaching, and this is going off towards negative infinity. There is unbounded behavior here. On the other side, on the right-hand side, it is also going off into positive infinity. There is an asymptote there, so clearly the function does not exist at 2. And the last one is the limit of f of x as x is approaching 3. From the left-hand side is about negative 1. From the right-hand side, also about negative 1. And so the function as x is approaching 3 has a limit of negative 1. If you did not get exactly that, but you're close, you tried to make a guess at a decimal or a half of a number or what have you, I think whether or not the limit exists in these things should still be the same if you're reading the graph in the same way. Anyways, that's the end of our lesson for tonight. Take care.